Very good morning to all. I am Dr. Devasis Mohanty, working as Assistant Professor in the Department of Mathematics, SR University, Warangal. So today I am going to teach you about the basic fundamentals and some problems related to Bayes theorem. So this Bayes theorem, that is understanding the conditional probability in reverse. So conditional probability means the events will be given and we need to calculate the probability of A divides B. Suppose A and B both events are given. So next start the lecture based on the Bayes theorem. So we'll start the lecture. So these are the prerequisites. That means what we need to find the Bayes theorem, to apply the Bayes theorem. So first of all, we need to use the sample space. That first one, sample space, then addition of the multiplication rule of the probability, then concept of the conditional probability. So here, students, look after this probability of A divide B, that equals to probability of A intersection B divided by probability of B. That is the conditional probability. That is the conditional probability. And the conditional probability B is not equals to 0. Okay. So, but in Bayes theorem, we need to understand about the reverse conditional probability. So this is about the conditional probability, but we need to understand the reverse conditional probability. So let's coming to our topic, Bayes theorem. So this is the definition, students. So that defines the A1, A2, and up to AN be mutually exclusive and exhaustive events. So we can write the formula probability of AI divided by B equals to probability of AI multiplied by probability of B divided by AI divided by sum of J equals to 1 to N probability of AJ multiplied by probability of B divided by. So here that AI means the prior probability and AI divided by B, that means the posterior probability of the given event AI and B. So this is the Bayes theorem. So next, coming to the next concept, that problem, drawing a red ball from a bag. So students, try to understand this question. First of all, try to understand this. So you have two bags. Okay. So two bags means bag one and bag two. Okay. So first bag, that bag one, that contains three red ball and seven blue ball. And the bag two, that contains five red ball and five blue ball. Okay, students. So here five red also and five blue ball also. That means probability of A1 equals to probability of A2 equals to 0.5. 0.5. Because total wall is, what is the total number of wall? Total number of wall is in the bag one. What is the total number of wall? 3 plus 7, that is 10. In the bag 2, what is the total number of wall? That is 5 plus 5, that is also 10. So out of 10, we are choosing the equal probability. That means the bag 2 contains only 5 red and 5 blue balls. So try to understand this concept. That means the probability of A1 equals to probability of A2 equals to 5 red and 5 blue. So that is 5 divided by 10. That is 0.5. Okay, understood? After that, what is asking, try to grab this. You randomly select one of the two bags with equal probability. That means that 0.5, that equal probability, randomly you have chosen within that two bags. Then you randomly draw one ball from chosen bag. Okay, from chosen bag, one ball you have chosen. So now, if the ball is red, so only red ball it is considering. What is the probability it comes from bag two? So try to understand this concept. So again, I am explaining this one. So bag one contains three red ball and seven blue ball. Okay. and bag 2 contains 5 red ball and 5 blue ball. Now, according to Bayes' formula, we need to calculate probability of P divided by, sorry, A2 divided by B. So we need to calculate the probability of A2 divided by B. So that is equals to probability of B divided by A2 multiplied by probability of A2 divided by of B. That formula we needed to use. We need to calculate. That means A2 means second event. Second. In the second event. That means back 2. Okay. So we need to calculate this. Okay, coming to the solution. So here it was written actually probability of A2 divided by B. That probability of B divided by A2 multiplied by probability of A2 divided by probability of B. Then we need to calculate the probability of B also. I will explain you how to calculate the probability of B. That is using the law of total probability we need to calculate. Okay, student. So here try to understand A1. That means the first event, the event of bag 1. Okay. So here A1 represents the event of bag 1. And A2 that represents the event of bag 2. Okay. And B is the event of drawing red ball. Okay, students. So based on this, we need to calculate the probability of A2 divided by B. That means A2 is the bag 2. From the bag 2, choosing the red ball. So that A2 divides B. That is using the conditional probability, reverse conditional probability. That Bayes theorem. Very interesting concept. So next coming to the solution. So you see, already I have discussed about this. So the probability of A2, A1, that is probability of A1, first event equals to probability of A2, second event, that is 0.5. That is the equal probability. That means 5 red and 5 ball. 5 red and 5 blue. Both equal. After that, the probability of drawing a red ball from each bag, we need to calculate. So red ball, we need to focus on the red ball. So coming to the question, bag 1 contains 3 red ball. Try to see this question. And bag 2 contains 5 red ball. So here, from the 10 balls, total 10 balls, we are choosing only red balls, right? So first of all, we need to calculate the probability of B divided by A1. That means out of the total probability, that is the choosing the red ball from the event 1, means the bag 1. So bag 1 contains how many red balls? Tell me. 3 red balls. Okay. So we are choosing 3 red balls out of total probability, that is 10. So probability of B by A1 is how much, students? Yes, tell me. 3 divided by 10. Good. Again, probability of, we need to calculate B by A2. That means second bag. So in the second bag, what is the probability of getting the red ball? It is 5. So 5 out of 10 ball, that is 5 by 10. So first is this one is 3 by 10. This one is 5 by 10. Okay, students. Then we'll apply the law of total probability. This is very important for you. Law of total probability. Law of the total probability. That law explains the probability of B equals to probability of B divided by A1 into probability of A1 plus probability of B divided by A2 multiplied by probability of A2. That will get the value of probability of B. Okay, students. So now already we have the data. Probability of B divides A1, that is 3 divided by 10. Already we have the data. Probability of A1, that is 0.5, means 5 divided by 10. Plus probability of B by A2. B divides A2, that is also 5 by 10 multiplied by 0.5. So we are getting finally that value 0.4. That is probability of B. So now we have all data. Means probability of B by A2 we already found. Probability of B by A2, that is what is the probability of B by A2? 5 divided by 10. Then probability of A2, that is also 5 divided by 10. Then probability of B, that is equal to 4 divided by 10. 4 divided by 10. Okay, students. Now here we will apply this for this formula. Okay, we are getting this value. 0.25, that is the probability of B by A2 into probability of A2, and probability of B is 0.4, that is that will get the value 0.625. So that way we are applying the Bayes theorem actually to find the probability of A2 divides B. That means choosing the what is A2, that is back 2. What is probability of B, that choosing the red ball. So choosing the red ball from the back two, that is probability of A2 divides B. That value we are getting using the Bayes formula, that is probability of B divides A2 multiplied by probability of A2 divided by probability of B. Finally, we are getting this value 0.625. Okay, students, all of you clear? Okay, again I am explaining. Actually, try to understand the question. What the question is asking about. Bag 1 contains 3 red balls and 7 blue balls, and bag 2 contains 5 red balls and 5 blue balls. Okay. From these two bags, we randomly select one of the two bags with equal probability. Equal probability means 5 red and 5 blue. We are already choosing that. So 5 red and 5 red and 5 blue, that equal probability, so that will be out of 10, 0.5 already we got from this. Okay, then you randomly draw one ball from the chosen bag. If the ball is red, try to understand the question. If the ball is red, what is the probability from bag 2? It is already mentioned here, from bag 2. Okay, from bag 2. So generally we are applying this formula actually. So first of all, you need to calculate the equal probability. After that, we need to find the probability of B divided by A1. That is 3 red ball we are choosing the out of 10. Probability of B divided by A2. That is 5 red ball we are choosing from 10. Okay, from this B by A1, B by A2 we got. Then we will apply the total law of total probability. That is probability of B. That probability of B by A1 into probability of A1 plus probability of B by A2 into probability of A2 using the law of total probability. That value we are getting 0.4. After that we substitute, finally we are getting the answer 0.62. I think all of you clear about it. Okay, 0.625. So this is all about the first question. Okay, students. So you see how Bayes theorem is so interesting. Actually, it finds the reverse conditional probability. Means whenever two events are given, and we need to find the probability of the second chance, that is A2 divides B. So how much interesting is it? So many real life applications are there. Okay. So coming to the next problem, we have two coins. Okay. So the first coin is a fair coin, and second coin is a biased coin. First is a fair, second is a biased. Okay, students. Now the probability of head, that is given 0.5. The probability, that means that is in a fair coin. In a biased coin, the probability of head equals to 0.75. Okay. Now try to understand the question. What the question is asking about. You randomly pick one of the two coins with equal probability. So with equal probability, we have chosen two coins. Try to understand. Equal probability means probability of A1 equals to probability of A2. That value we are getting equal probability, and toss it. Then the result is head. The only result we are getting, that is head. There you can see from the question also. Now, what is the probability that you picked coin 2? So second coin it is asking about. Now, tell me what is the probability of A1 and probability of A2 equals to probability of A2. That means in the fair coin which we have chosen, that means in the fair coin we will get the equal value, that is 0.5. Okay. Next, coming to the solution. So this is the formula. So this formula is applicable only because try to understand in the last part what is the probability that you pick the coin 2. Coin 2. Coin 2 means that probability we need to find A2 divides B. Okay. A2 divides B, that using the same formula, probability of B divides A2 multiplied by probability of A2 divided by probability of B. Okay, students. So we will apply only this formula, that we are able to find the probability that you picked in coin 2. That is probability of A2 divides B. Okay, students. Next, we'll see. So this is the formula. You can see here. This is the formula. Next, see the solution. Yes. So probability of A2, A1 and probability equals to probability of A2. That is equals to 0.5. Why 0.5? Because the probability of heads in a fair coin. What is the probability of head? That is 0.5. So that 0.5 will give us the probability of A1 is that means in the first event and the second event. That means for a pair also, for a vice also, we will get the equal probability that is 0.5. Now we'll come into the most important thing, that is we need to calculate the probability of B divides A1 and B divides A2. That already we have done in the first question, so no need to worry about that. I'll explain that the probability of getting ahead with each coin we need to calculate. So how to calculate this? Now tell me what is the probability of head in a fair coin? 0.5 for fair coin. What is the probability of head in biased coin? 0.75 in biased. Okay. So this probability of head getting in the fair coin. That is probability of B divides A1. That means the first event, that is the fair coin, we are getting the result 0.5. Okay, students. Next, the probability of head we are getting in the case of biased coin. Biased coin, that is probability of B divides A2, that equals to 0.75. We are getting here. That is in case of the biased coin. So we have the data, that is we are getting probability of A1 equals to probability of A2 equals to 0.5, and B by A1 and B by A2 we are getting that is 0.75. Then what we need students to do, that we have to calculate the total probability, that is probability of B. How to calculate that? Yes, tell me how to calculate that. What is the formula? Probability of B divides A1 multiplied by probability of A1 plus probability of B divides A2 multiplied by probability of A2. That is the law of total probability. Law of the total probability. Okay, students. So this is actually this law of total probability. We are using that probability of B divides A1. That means the first coin, that is the fair coin, we are choosing from the total probability, that is 0.5. That is 5 divided by 10. We are choosing 0.5. Again, probability of A2 is also 0.5. Probability of B A2 again 0.5, and probability of B by A2 is 0.75. So 0.5 multiplied by 0.5 plus 0.75, that is probability of B by A2 multiplied by 0.5, that is probability of A2. That result we are getting 0.625. Okay. Okay, students. So this is the probability of B. We are calculating 0.625. We are getting the probability of B using the law of total probability. So we have the equal probability, that is probability of A1, A2, that is 0.5. We have the probability of B by A1, this B by A2, that is B by A1 is 0.5 and B by A2 is 0.75. Then we need to apply the formula of Bayes theorem. What is the formula? Probability of A2 divides B equals to probability of B divides A2 multiplied by probability of A2 divided by probability of B. That value we are getting 0.75, that is the probability of B by A2, and 0.5 is the probability of A2 divided by total probability, that is 0.625. That value we will get 0.6. Okay, students. So this value will get that is the answer 0.6. So 0.6 is the probability that we pick from the coin 2. That is probability of B divided by A2, that into probability of A2 divided by probability of A2 divided by probability of B. That we need to find, that is the probability of A2 divided by B. That value. That what is the probability that you picked 0.2? That result is 0.6. Okay, students, understood? Okay, so this is about solving the problems using the Bayes theorem. Actually, we are calculating the probability of A2 divided by B. That means the second event was the second event we are calculating with respect to the total probability to get the expression. Okay, that means the coin two or event two or back two, like that we need to calculate the probability. So we need to apply the bus. Okay, students. Next, coming to the third question. That is very important and very interesting question. So try to understand this. In a certain college, 25% of boys and 10% of girls are studying mathematics. Okay. The girl constitutes 60% of the student body. So girl constitute 60% of the student body. So if girl constitutes 60%, then what is the boy will constitute? Out of total is 100%. So what is the probability of boys? That will be 40%, right? That will be 40% of the student body. That boy will constitute the 40% of the student body, right? Now try to understand the first question. That is, what is the probability that mathematics is being studied? So to find that what is the probability of mathematics is being studied, we need to apply that formula. That is, we need to calculate the probability of math. So we need to apply the law of total probability to calculate this. The law of total probability to calculate the probability of mathematics. So with respect to probability of mathematics studies boys, and with respect to the probability mathematics studies girls. So you need to see over that. Okay. And second question is, if a student is selected at random and it's found to be studying mathematics, so find the probability that student is girl. So probability of Z divided by M. Probability of girl studying mathematics we need to calculate, and probability of B divided by M. That means we need to calculate that is a boy. Okay, those things we need to calculate. Okay, students. Next, coming to the solution. So what data is given? Already I have discussed about that. The that here I have discussed 60% is girl means 40% will be the boys of the student body. So probability of boys 40% that means of the student body probability of boys 40 divided by 100 0.4, and probability of girl that is already given in the question 60%. 60% boys, 40%, sorry, 40% is boys, 60% is girl. Now we need to calculate the probability of mathematics studying that girls are, sorry, boys are studying mathematics. So probability of M divided by B we need to calculate. So M divided by B, go to the question. 25% of the boy and 10% of the girls are studying mathematics. Okay, so 25% of the boys studying mathematics. That is a probability of M by B is 25 divided by 100. Again, probability of M by G. Then that means girls studying mathematics. What is the probability? Already given in the question, 10%. So students, already I have discussed. So what we need to calculate? We need to calculate the probability of M, means probability of mathematics. You need to see the question. What is the probability that mathematics is being studied? So probability of M means the probability of mathematics is being studied. So that we need to calculate using this formula, probability of M by B. That means probability of boys studying mathematics into probability of B. That means probability of boys plus probability of M divides Z, that is probability of girls studying mathematics in multiplied by probability of Z, that is probability of girls. That is the law of total probability. Already we have seen law of total probability. That means that value we need to calculate. That is probability of B. We know the formula B by A2 into probability of A2 plus probability of B by A1 into probability of A1. So similar formula we need to apply here to find the probability of mathematics is being studied. So that is first one we need to apply that probability of boys studying mathematics into probability of boys plus probability of girls studying mathematics into probability of girls. So we have already these data. So we'll apply the data and we'll get the result as 4 divided by 25. Okay, that is probability of M by B is 25, 0.25, probability of B is 0.4, and probability M by Z is that is 0.1, and probability of Z is 0.6. That value will apply to get to 4 by 25. Okay, Okay, students. So that first question we already solved using the law of total probability. Now coming to the second question. If a student is select at random, so randomly we are choosing students that may be a boy or girl, and if it found to studying mathematics, find the probability of the student is a girl. So randomly first we chosen out of the total students, then we need to calculate the probability that student is a girl student. So we need to calculate the probability of Z divided by N. Reverse, that is reverse conditional probability. That is the wise formula here we are applying to calculate the girls student that studying mathematics. So normally we know the formula probability of A2 divides B equals to probability of B divides A2 into probability of A2 divides probability of B. Similar procedure we need to apply here to calculate the probability of girl studying mathematics, that is probability of mathematics is being studied by the girl, that is M divides G into probability of girls divided by the probability of mathematics. The same formula we are applying, that we will get, that is already we have the entire probability of M divides G and probability of G and M, so we will find the answer, that is 3 by 8. Similarly, third question is, what a boy means what is the find the probability that the student is boy that's studying mathematics, that we need to calculate. So how to calculate this? Let us see using the same formula only. That is the formula of the Bayes theorem. Bayes formula we need to apply here. So this is very simple concept. So we need to calculate the probability of B divides M, that equals to probability of M divides B multiplied by probability of B divided by probability of M. Okay, students. So this is about we are calculating the probability of B by M. That means we are calculating the probability of the boy, a boy student studying mathematics. Okay. So already we have probability of M by B. What is the probability of M by B? Let's see. That is 25 by 100 multiplied by probability of B. What is the probability of B? Probability of B is 40 by 100 divide probability of M. Hence number of students studying mathematics. What is that? 4 by 25. So that is 4 by 25. Okay. So that value we have calculated. That value is 5 by 8. Okay, students. So this is the number of boy studying mathematics. Okay. So this problem is very important for. So you need to practice that frequently. Next, coming to the problem one, consider a manufacturing firm that receives a shipment of parts from two suppliers. Two suppliers are there, A1 and A2. So supplier one, that A1 receives that supplier one, A2 receives the supplier two. So we obtain 65% of our part from the supplier one. So supplier one we are getting 65%, and 35% here we are getting from the supplier two. So that percentage is also given. Supplier one is 98%, then sub good parts is 2%, percentage of good parts is supplier two is 95%, percentage of good parts is 5%. Okay, students. So we need to calculate the probability of Z divides A1. That is 98%. So 0.0.98. Then probability of B divides A2. That is 2% of the good part, 0.02. Similarly, probability of Z divided by A2, 0.95, 95%. Probability of B divides A2, that is 0.05, 5%. Okay, each experiment we are finding there. Okay, students, each experiment that outcome is two events. So here you can see. Okay, so this we are getting this means connection. Here the connection is that A1 that connects A1B. Here it is A1Z. Here it is A2Z. Here it is A2B. Okay, students. So that we need to apply here to find that. Okay, coming to the next problem. A box contains three coins. So a box contains three coins. First one is a fair coin. Second one is a double-headed coin. And third one is a biased coin. Third one is a biased coin. And that biased coin probability of H is head is 0.75. So what is the probability that chosen coin is coin B? So here is it is given the coin B. That means head H of 0.5, that is coin A, and tail is also 0.5. H of H head is 1. Head is in case of coin C, head is 0.75. In case of coin C, tail is 0.25. Okay, students. Next, this is the solution. This is the solution. So here in the coin one, see the coin one. The coin one, that is coin A, that is a fair coin. Fair coin, the probability of head, what is the probability of head? 0.5. And what is the probability of tail? That is also 0.5, equal probability. Then coin B, what is the probability of double headed? That is probability of head, that is 1. And what is the probability of head in coin C? Already it is given in the problem, na? 0.75. What is the probability of T means tail? That is 0.25. Then we'll use that bias formula. We'll use the bias formula to calculate this probability of A intersection H. That means 1 by 3 multiplied by 0.5. Probability of B intersection H, only bias formula very easy. That is 1 by 3 multiplied by 1. Probability of C intersection H, only heads, 1 by 3 multiplied by 0.75. Okay, so 1 by 3 is multiplied in the 3. As the each coin probability is 1 by 3. Already it is mentioned here in the question, 1 by 3. So that we are applying this. Okay, students. So after applying this, we need to calculate the probability of B by H. Probability of B divided by H equals to probability of B intersection H divided by probability of A intersection H plus probability of B intersection H plus probability of C intersection H. So that value we will get 4 by, that is the direction. Okay. So you see how Bayes theorem can applicable to the problems, application oriented also. Next problem, we'll come into the next problem. Machine A, here try to understand the question. Machine A is 30% of the item and 2% is defective. B is 45% of the item and 1% is defective. C is 25% of the item and 3% is. So here is a complete scenario, that is machine A connects 0.3 and 0.2 and 0.3 is 0.98, means for defective it is 0.02, for non-defective it is 0.98. For similarly, machine B 0.01, that is for defective, non-defective is 0.98. Means 0.02 will deduct from 100, that is 0.98. 0.001 is deduct from the 100, that is 0.98. So coming to the solution, so what is the probability we need to calculate? The machine A, that is 0.30. Machine B, that is 45%, means 0.45. Machine C, that is 25, means 0.25. Okay, so we need to apply the Bayes formula, that is probability of A intersection D, that is equals to 0. Machine A is 30 multiplied by 0.02. Coming from the 100, that means 0.98 will deduct from that, it will get 0.02 is the defective case. Similarly, probability of B intersection D, that is 0.45 multiplied by that 99%, that means 0.01. And here third one, probability of C intersection D, that is 97% will deduct. for the defective case. So 0.25 into 0.03 will get. Finally, we'll get this value probability of C divides D. That value will get probability of C intersection B divided by probability of A intersection B plus probability of B intersection B plus probability of C intersection B. So applying all these values, we'll get this as 5 by 12, right? Divided by 12. Okay. So these are very interesting and very simple problems. So again, one problem is there. So this you need to practice. 60% of the students are from science, and probability of science is 0.6. 40% from arts, and probability of arts equal to 0.4. Then among the science students, 70% pass the exam, and arts student 50% pass the exam. Then we need to calculate the probability of student passing from the science. P divided by S. Similar formula we need to calculate. That we need to use the law of total probability. Okay, law of total probability to calculate the probability of S using the data given. So that the answer is, that is 21 divided by 31. Just to verify it. Okay. Next exercise problem we need to see. Exercise problem. Next is an email system classifies emails as spam or not spam. So 20% of all email are spam. So the filter correctly flags spam with a probability of 0.9, and the filter incorrectly flags the non-spam with a probability of 0.05. So we need to calculate the probability of actual spam. Probability of actually spam we need to calculate. So how to calculate that? Probability of actually spam. So already data given for the 20% of the emails are spam. And the filter the correctly flagged spam is, that is probability is 0.9. And that filter incorrectly flag is 0.05. So that will apply as a wise formula to calculate this. That same formula, probability of A2 divided by B, we need to calculate. That is probability of B divided by A2 into probability of A2 divided by probability of B. Same formula we need to apply to calculate. We just check that answer. That answer is 9 divided by 11 is given. Okay, students. So this is all about the Bayes formula. Okay. So any doubt anywhere, please ask me. So Bayes theorem is very important concept because it carries the reverse conditional probability. That is a very important topic in the probability. So you need to calculate the A2 divided by B. That means from the total probability, you need to calculate the probability of the second event. So it is very useful formula, and it implicates the reverse conditional probability. So it has a huge implication in the engineering science also. Okay, students. So this is all about the today's lecture. Okay, that Bayes theorem. Okay, students. So thank you for listening my lecture. So we'll continue. Okay, thank you also.